Okay, so let me just do a little introduction to guest speaker here. This is, of course, a person who really doesn't need introduction to this audience. He's, of course, our MBCA technical chair. He has been a member of MBCA since 1978. He was a charter member of his own section, Smoky Mountain section. He was also president there. He's been national director at large. He's been a national treasurer. He has spoken to MBCA technical sessions since about 1986 at every national meeting we've ever had, including Mercedes Freude here back in November. He's got a great background for doing all this Mercedes technical stuff because he's a nuclear engineer, worked in the nuclear industry before he retired, which I think is just a great background for working on Mercedes. He's had at least 15 Mercedes. He currently has a GLK 350, works on his own car, has a company called Performance Analysis that comes up with some unattainable items for Mercedes, especially the climate control system servo, rebuilds the control console for the HVAC systems. And of all the things he's a Mercedes technical expert on, this is probably his favorite topic and probably his strongest topic. So we really wanted to ask him to present this one to us. And so please join me in welcoming George Murphy, National Technical Advisor for the HVAC systems on the 107 cars. Thanks, George. Thanks for doing this.
Oh, glad to do it. It's a lot of fun. I enjoy it, and as I do all the tech sessions. So I'll get this thing up on the screen. I hope we can get it working now.
Yeah, I have no doubt.
That better?
That's it. We see it. Absolutely.
Skill and science once again prevails. Okay. Well, as the title is, obviously we're going to just talk about the 107 climate controls. They're very similar to the sedans, except in certain cases. But I'll answer questions even on the sedans if you want. But let's stick with the 107s and U.S. models. If anybody has a gray market car, they may have a slightly different system, and they can ask me questions on those if they'd like. But just be aware that the gray market may have a different one. The 107s came with three different systems. The first ones, of course, 72 to 77, you could recognize it with these buttons, the levers and all that. 78, they went over to the automatic climate control, cursed by many, and I'm about the only one that can fix them now. Then starting in 82 with the 380 SL, they went to the third system that was out there, and all you see really on the panel is these buttons, but this is the back of it, the controls. So that's what we're going to be discussing here. This is just a listing of the different types, what we call the manual system, and the years and models they were, and then the first auto climate control, and then later on 560 SLs had their own, slightly different from the 380 SL. So the first ones we'll talk about is of course the manual control. And really, I've had this in my sedans and a few SLs. I really like this better than the automatic. As you can see, it's very versatile. You can adjust the left and right side heat. You can adjust where the air goes. This lever here gives you more or less airflow to the footwell. This lever here up and down gives you more or less air to the controls for defrosting. You can it has a blower speed switch here, usually 4 or 5 speeds, and then the compressor control here, which is really later on I'll talk about what's called the evaporator temperature regulator. What this is, okay? Some people don't know what this means. All that is an indication of your levers for defrost, full defrost. That is all 4 levers up. That means maximum heat and maximum airflow to the windshield. So that's the defrost function. European cars is carried over to that you have to have indicate to the driver how to get the windshield clean. And this is how you do it in those very early ones that way. Of course, the US models have to have the fasten seatbelt sign. So, but it's a nice system, not hard to work on either. So there's 2 versions of the manual system only by the controls out. And the first one, on the firewall, left side. Now, I talk about left side, I mean if you're sitting in the driver's seat. Left side is, of course, the steering wheel side. So if you open the hood, you look on the left side of the firewall, this is what you see in the very early version 1 manual controls. It's got these vacuum controls here. This is the hot water valve. It doesn't throttle, it's either open or closed, depending on the position of those levers. The second version, this is the only thing I can really show the difference is, only on the second version is only on the firewall, you'll always see this hot water valve. That's all you'll see. These devices here, the levers control the vacuum routing switches. And of course, you've got, this is the input from the ETR, the compressor switch and all that. So the way that the system works is it moves flaps on the left side or right side to give more or less hot air to your footwell. So the control, actually, if you want, this goes to full heat, full hot water flow, but the airflow through the heater is adjusted by these flaps. So that's how it's done in the second version manual control. And again, you can use this chart to see where your car lies in the spectrum of the car. You have like an 044 car starting with this last 6 digits. So, but just by looking at it, you can see what you've got. This is the device behind the panel on the version 2 controls, and the levers fit into here. The vacuum switches are here and here, and usually what happens in time goes by, they just vibrate loose. The nuts and bolts are loose. This whole thing doesn't work right. You have full heat all the time. And if you understand how the system works, when the heat lever, the red ones are all the way down, that should shut off the vacuum to the hot water valve, and you have no hot water flowing. Keep that in mind when you're working on the system. That's how it's supposed to be. But that's what these devices behind the control panel look like. This. You pull the panel off. So we can get on with that. If there are any questions on the manual system before we get away from it? Good. Okay, the cursed automatic climate control system started in the SLs in '78. Came in the sedans actually earlier, but in '76s. But anyway, it's really a Chrysler design. Came over from Chrysler. They used in '68 to '75. And believe it or not, about half my sales now are to Chrysler owners. They have this thing and they want this climate control valve that I repair. But just so you know, the 123s from '78 to '80 had it. The 116s had it from '76 to '80, all these here. And of course, '78 to '81 on the SLs. The only '81 SL that had it was a 380 SL. So keep that in mind. If you have an '82 380 SL, it's the newer next system up. Of course, you recognize this panel. These are the controls, vertical row of push buttons. There's a compressor switch and the temperature wheel. And if the paint's not worn off, this blue thing here indicates control of the compressor is done for auto high and auto low only. Compressor runs in these two all the time. But here you can turn the compressor off and on in auto high or auto low. And that's what this little blue box means. And if you have a pristine panel, never been touched, the blue is still there. And of course, you can adjust the temperature in the car by turning the wheel up or down. Pretty straightforward as far as that goes. But, sometimes it fails a lot. This schematically is showing how the temperature control is accomplished. There's a nice little video here. Here's a picture of the climate control servo. There's a feedback potentiometer inside. So that's this variable resistance here. And it's chained with the wheel, which is here. This is the red, white, and blue wheel. And it's chained in the in-car temperature sensor. That's this one here. And then the ambient temperature, that's the incoming air. That's this one here. And the amplifier, of course, reads these and sends a signal. Those wires aren't shown. Sends a signal to the servo to move one way or the other to adjust the blower speeds, to adjust vacuum distribution. But that schematically is how this thing works. By the way, this ambient sensor, this is located in the incoming air in the blower housing. If you take that cover off the blower, that sensor, it sticks into that housing. So it's reading the air coming in. The in-car sensor, we'll get to that. in the SLs, in the center of the dash, a little grill. Of course, the wheel, that's obvious. We all know where that is. That's staring right at you. So the major controls in this system, of course, is the cursed servo. This is a picture of a plastic one. We overhaul these. We make new, and we use aluminum body for this part here, because this usually cracks with thermal cycling. They only last about 2 years. Mercedes-Benz wants $2,000 for them. This is what the amplifier looks like. That drives the servo. And then there's an auxiliary water pump, which is really only there to provide the constant heating when the engine's idling. You'll know that this pump isn't working because your heat goes away when you come to a stop sign. Then you drive off, the heat comes back. That's because this pump isn't working. This is the internals of the servo. Nice up here. Those are all those vacuum hoses you see. There's what 9 of them. These here are the 2 electrical connectors, lower speeds here, and this is controls. Behind number 10 is a gear train driven by this little motor here. And he drives some gears, and these gears go back and forth. They drive this shaft up and down. This is the water valve that goes up and down in this chamber to admit more or less hot water to the heater. Of course, when you're going, when this thing is turned completely off, that's why there's a poppet valve in here. So this pressure could push against the spring and return it back to the engine. That's how this is. This device down here is, there's always 2 vacuum hoses that come down to it. This is supposed to delay blower speed or blower startup on a cold morning. When this gets warm enough in here, about 105 degrees coolant temperature, this little device opens up, admits vacuum to the blower vacuum switch, and lets the blower start. You can bypass it just by connecting the 2 vacuum hoses together rather and bypass that stupid thing. But it's cause of confusion to a lot of people. This is what they look like when they fail. This the internals here, you can see all the gook on the gears and the motor. This is not too bad. Some are even worse than this. But they get a crack in that plastic part where this shaft goes down, and it lets antifreeze get in here, and of course it deposits on the gear. They eventually jam up and nothing happens. They'll blow out the amplifier if you don't fix it right away. But this is a failed plastic servo is what they look like. This is the complex vacuum system for that system. And this is what I call version 2 for the 107s. There's an earlier version which has slightly different main air left and right vacuum diaphragms, but most of them you'll see have these things here, main left and right main air coming in. If you go to defrost, there's this actuator here actually has two positions, and it's got 2 diaphragms. One is about 10%, one is full. The 10% is even when you're in air conditioning, cooling the hot, it runs 10% to the windshield. That's what this accomplishes. Of course, this is when this was activated, it blows all the air to your leg room. When this is on, it blows air out the center vent. Schematically, this is the back of the push button switch that you see, the 5 push buttons. And depending on which ones you push, it routes vacuum to the different portions here. These are some of the control valves underneath there. I have never sold any of these. They're very reliable. Same with this little device and this little device. Schematically, this dotted line is the firewall. This is the stuff under the hood. This is the source of vacuum for the system, comes off the engine manifold. This is a vacuum reservoir, stores up vacuum. There's a little check valve here, but it communicates to the push button panel. And of course, from there, depending on which button you push, different things happen. And of course, when the servo moves back and forth, different vacuum paths are accomplished. The shop manual actually shows almost 10 different pictures of this, depending on the position of this push button panel. So I just grabbed the general one. Now, something to keep in mind, if you've got your glove compartment pulled, you're working around in there, this device here, number 38, is green electrical wires, a coil of wire all coiled up and tied up. One end of that green wire is plugged into the vacuum hose. What? Electrical wire into a vacuum hose. Yes, that's correct. It's called a vent. When you turn the car off, it exhausts all the vacuum in here, so they're not under constant vacuum. That's the only purpose of it. Leave it in there, leave it where it is, plugged in. Don't pull it up and throw it away like some mechanics do. And then they call me and wonder why their system doesn't work. Because if you have a big vacuum leak back here, your blower won't work and your compressor may not work, because that's what these two switches do. So you must have no vacuum leaks back here. There is a test point up here, this thing right here. If you look around back in there, you'll see it's just a little a T with a plug in it. Leave it in there. That's a test point. If you had the factory test manual for this, that's where you'd plug it in. Or you can put your vacuum gauge on this little thing and see if you've got a leak here. You can, if you have a smoke machine, inject smoke in here and it'll show you if you have any other leaks. So it's kind of a handy place to measure vacuum or to do leak testing with a smoke machine. And it's behind the glove compartment. All this is behind the glove compartment. So electrically, this is how the defroster works. When you push the frost button, there's a double pole relay back in there. It does two things. One contact runs the blower, zoom, full speed, if you'll notice. Doesn't even go through the resistors. The other contact runs the compressor, provided you have enough Freon gas. You don't have a low pressure cutout. Low Freon will open the switch and the compressor won't work. Here's what's called the evaporator temperature regulator. It's a little box in there that controls the clutch, assuming everything is right. It actuates the clutch off on the compressor. I'll get into how this works, but that's an important portion, and to know where it is. And I've got instructions. I'll get into how to take it out of there and how to adjust it. These cars are so old. This ETR has probably gotten lazy, and it cycles this clutch, so it cuts out at 55 degrees, maybe cools down to 65. You can adjust this to give you cooling down to 55 and cut off at 35 if you wanted to. You can. This is adjustable, and you can adjust it and lubricate it and get better cooling, especially down south where you really want good cooling. You can actually do that. I have a whole double pages of how to do this. You'll need an ice bath and some hot water in your kitchen and a thermometer, and we can actually work on that switch. So it's very important. There's another electrical portion here in the auto high, auto low. What happens? Your power supply comes through the air conditioning starter relay, which is found only up to about 1980. But anyway, you have to worry about that. It's there. And then you have a compressor switch, which, and I got into that. Here's how the compressor switch works. And that's a vacuum switch, see, because you push either one of these, it applies vacuum to that. And of course, when it picks up, it runs the auxiliary water pump, provided the incoming air temperature is below 65 Fahrenheit. That's when this water pump will work. So on a cold winter day, you're cruising along, you got your heat where you want it, you come to a stop sign or traffic light, and all of a sudden your heater starts to go away. The blower's running, but it's getting cool. That's because this pump isn't working. It's a cold day, of course, this switch is telling it to work, but if this is jammed up, burnout, whatever, that's what happens. And then when you drive off, it gets hot again. So that water pump is only there to provide constant heat at idle. That's just assuming the incoming air is below 65 Fahrenheit. Measured distance switch, which is found in the blower housing underneath. We'll get into that. Any questions on this, generally how it works?
George, yeah, we have a couple of questions on this. I think you answered Rusty Phillips' one. His question was, what's the purpose of the wire plugged into the vacuum T at 38? I think you got that one. Fred asks, he says he has no cabin heat in a 1990 560 SEC. I guess that's actually the next system. I think maybe I'll hold that.
In an SEC, that's a 126 car. It's a different system.
Yeah, okay. And we'll get that to the, I'll ask that one when we get to the end. Greg Whitehouse asks, when my ACC is on, he says Chrysler W116 300 SD, my engine, when stops immediately when I turn the car off. However, when the ACC is off, the engine slowly comes to a stop. And with the ACC off, there is a small amount of air coming out of the defroster. So basically he's saying that the engine stops immediately when he turns the car off with the AC on, and it takes longer for it to shut off when the AC
So it's a
is
diesel.
off.
Must be a diesel.
It is a diesel. It's an SD.
Okay, that's because the shutoff actuator on the back end of the diesel injection pump is under one case, when you turn it off, it shuts off right away. The other case, there's enough vacuum to keep it energized for a few seconds before it lets the engine shut off.
Oh, wow, neat. A vacuum issue.
Yeah, it's on the back of the injection pump on the diesels. There are no diesel SLs unless somebody's fool enough to put a diesel engine in one of these cars. Okay.
And one of the other questions is, this is from Sam Catveth. Is it best practice to turn the compressor off and the AC off when starting the car, or is that a myth? He says he's talking about 1970 cars and not modern ones.
Oops, I'm sorry. That's the purpose of this starter relay. That cuts all this stuff out while you're cranking the engine. This is your starter circuit.
Mm-hmm.
Okay, so that's what this does. So it's under the hood. I have to look up where the thing is, but generally that's why it's there, is to turn off the compressor and everything else while you're cranking the engine. Once the engine starts, everything is, you're okay.
Mm-hmm. Got it. Okay. And Lawrence Foster asks, and you mentioned this briefly, how effective is a smoke machine for finding leaking connectors and actuators?
It's probably the best way to find leaks. Either inject smoke into here from under the hood. It'll push smoke through all these lines, and you see it coming out someplace. Aha, there's my leak. And usually you'll get a leak here. You might have a leak where some of these hoses connect to these things, or you'll see smoke coming out. A trick I use, you don't want to buy new hose. My gosh, this is all one big harness of hoses. But with time, these cars are so old, where the hose connects to the device is kind of enlarged. So pull it off, take your wire cutters and snip off 1/8 of an inch of the rubber and plug it back in again. It'll be nice and tight and it'll quit leaking. But a smoke machine is the best way to find leaks. If your favorite mechanic has one, and he's going to need one for all the newer cars, there's so much vacuum on them. But even on these cars, he can inject smoke either here or here. It's probably easier here, but if he pulls a glove compartment, you got to pull a glove compartment and look and see if you have any leaks under here. So either way, you can put smoke into it and look for leaks.
And Gus Beek mentions that he missed the answer on the green wire at number 38. Since you're on that slide again, you might as well mention that.
This is where it is. If you pull your glove compartment, it's just sitting right under the bottom of the glove compartment box. So if you pull the box out and there's this green wire, it's a coil. It's all coiled up, it just lays there. But one end of it is plugged into one of the rubber hoses right here. It's plugged in. It's a green wire. And it's called Mercedes Benz at the bottom here has all explanation for all these. It's a leak point. And when you turn the car off, it slowly exhausts the vacuum out of this whole thing. So it's just slowly lets it off. That's all it's for. There's a little bit of course, when the car is running, you've applied vacuum here from the intake manifold through here, whatever button you push. These things all have vacuum on them. And there's a slight amount of vacuum pulled in through this coil of wire, because I don't know how long it is. I never uncoiled one. I think it's about 6 feet long, but it's all coiled up and wrapped up. Just leave it alone. Make sure one end is plugged in. Make sure it's there. Some mechanics throw it away. Then they call me because they can't figure out what's going on.
Okay. Now, Greg's question on the 300 SD, the W116, he says with his ACC off, there is a small amount of air coming out of the defroster. And is that normal?
No, all these should shut down. Probably in the 116, there's one of these, okay? And it's probably gotten lazy when the diaphragms has holes in. By the way, I manufactured the rubber diaphragms for these. I'm the only manufacturer in the whole world. I ship the rubber diaphragms all over the world because nobody has them. They have the plastic ones, they have the plastic, but the rubber's shot. So we manufacture them. These diaphragms here, they're each different, but I have both of those. And of course, these, this, and this, all the same. But we manufacture those now. Company not far from my house, about 80 miles away, makes them up for me, molds them. I have the molds.
Neat. Okay, we have a few more questions, but my suggestion might be to go ahead because some of the questions are getting into the next system, and then I'll catch up at your next pause.
Okay. Yeah. There. Okay. This is a photograph of underneath the hood. Oh, here's the green wire. See it? There it is, right there. There's the green wire. Too bad it's in the color picture. Okay, and this is one of the vacuum actuators or fresh air ones. But I wanted to include this because here's the ETR switch. Remember we talked about that? That's the ETR. You can recognize it's got black tape wrapped around it and then wool insulation and 2 wires connected to it. You can get it out of there. It's a bear. There's a couple of screws. Now, if you want to adjust yours and you undo these wires and the 2 screws or 1 or 2 screws hold it into the plastic heater box over here, pull it out carefully because it has a long capillary tube that operates this switch. That capillary tube is in the evaporator. And that's how the signal, the evaporator temperature is transmitted to this ETR. It is the expansion and contraction of the gas inside that capillary tube. So be very careful. If you break it, you get to buy a new ETR switch with a new capillary. Also, note that the capillary may have a piece of wire around it or paint, indicating how far in it pokes into the evaporator. Just be aware of that if you're going to work on that. But again, contact me for the procedure of working on that ETR switch. I've done a number of them, and it's kind of fun to get them so they work really good and really cool your car. So like, you know, it turns on at 50 degrees and off at 35 degrees. But an old one, after 30 years, you know, they cut off the compressor when you only got, say, 42 or 45 degrees, and they turned on at 65. Well, that's not enough. You want colder air. You can get it with an adjustable ETR switch. By the way, these are no longer found on the later models after 81. Okay. This is a blower circuit, just to show you there's a bunch of resistors at each, it doesn't show all the wires here, but in the automatic climate control, you've got 6 different speeds from 1, 2, 3, 4, and 5. And this is how they're accomplished. And there is a switch. Again, this blower master switch must get vacuum in auto high or auto low, or else the blower won't work. So this is how that's accomplished through here. There's a vacuum switch valve inside the servo. Here's your cold engine lockout I talked about. That's that little switch on the bottom of the servo. But in defrost, this is the vacuum path. So understand, if you're in auto high or auto low, this switch must be picked up also. So to run the blower. If you got a leak, that doesn't pick up, your blower doesn't run. Any more questions on the section 2, ACC 2? I don't know why they say 2. It's number 1 to me, but it's the first auto climate control. But anyway.
Yeah, I think we have at least one more on this system. Gene B asks, his 79 450 SL continues to get outside air coming into the cabin. He says he's replaced the servo with an electronic version similar to unwired tools. He says, and he says he thinks he has a vacuum leak someplace. He's tested all the vacuum pods except for one.
Well,
he's asking,
that system that replaces the servo doesn't operate all these properly. So your main air left and right, you're still getting air in because it's not operating these properly. I don't know how they do that with that system, but it takes out the servo, it takes this out. And I don't know how they accomplish all the controls of vacuum underneath the dash with that add-on system. But probably, I got a feeling it doesn't operate the main air left and right. So that's why you're still getting air in even though it's shut off. Just go to the manufacturer of that add-on system. I think it's Unwired Tools makes that.
David Bruckman asks, after the servo, what is the most troublesome component of ACC2? He says he has a 79 W16 300 SD and he has replaced the servo. Okay.
Well, the amplifier is the next one. If the servo is not repaired, in other words, if the servo locks up because it gets jammed with antifreeze and the gears can't turn in there, eventually it'll burn out the amplifier. So you get to buy a new amplifier from me or rebuild. There are no new ones. Well, there may be a few left, but there are several $100s from Mercedes Benz. I've got them for $149, but you can burn out the amplifier. So the two go together. A jam servo that's hung up will eventually burn out the amplifier. You can tell by pull the glove compartment, put your hand on the amplifier. If it's hot, it's really, really hot, the servo is jammed up. They do get warm during operation. If you look inside that amplifier, you'll see some ceramic resistors that get pretty warm, but they get really hot and burn out the solder joints, and the amplifier has to be sent to me for repair. We can fix the newer style amplifiers. If you recall, we go back, this is the only ones we can fix. You see, the earlier ones had a little plastic part up here like this. I can't fix those because the internal parts are no longer available. So if you want one of these and you've got the old one in there, try to find one of these in a junkyard for a core, because that's what you've got to send me. I've got to have a core that looks like this without that little plastic at the top. Okay, we can rebuild these, and they're fully tested before they go out, 1 year warranty and all that. But these two go together. If this is not working, it can over time burn this out.
Okay. And we have Robert Stelfox asked, do you still sell diaphragms for the rebuildable vacuum valves?
Yes. Yeah, diaphragms, here they are. We have them. All of Mercedes up to 89, 126. I have the rubber diaphragms, repair them. Even the 124s now, I have a whole set to repair the 124 HVAC. We haven't gotten it. We're not going to get into that one, but that's even more complicated. But yes, these diaphragms here that I manufacture are good up through late 126 and 124s.
Okay. I think we've covered all the ACC2 questions.
Okay. ACC3, you can recognize it's got a horizontal row of push buttons like you see here. There's your blower control switches. There's a low speed only, high speed only, and then automatic. The blower speed is, there's a box in there that adjusts the blower speed automatic. And of course, here's your temperature control, very similar to the earlier systems. Some electronics are contained inside here, but there's more electronics in this system than just this box, and we'll get into it. This is the vacuum layout for ACC3. It's a little bit less complicated. It's got 4 vacuum switches here. These are controlled by a temperature control switch. Here's your fresh air. These here. We have diaphragms to fit these. They're the same diaphragm. And of course, here's your defrost actuator. Here's your center vent actuator. But you can see they're a little less complicated. There's little check valves in here and little orifices to slow down the action of these so they don't slam shut or slam open. Mercedes-Benz wants a little bit of refinement in their system, so it slowly changes. So that's what these little orifices here, you'll see them in here, stuff like that. And then of course, there's a vacuum reservoir underneath one of the fenders. And this is the source of vacuum on the intake manifold. And you see where it comes down to these 4 switches. And these are controlled by the next slide we'll get into. So this is your system to work on. You can see it's a little less complicated.
One of the questions we have is that wire we were talking about previously in a 560 SL?
In a 560 SL? Yes, it is. It's there. Yeah, because that's ACC2. Oh, no, wait, pardon me. Let me back up a minute. No, a 560 SL, this has this. And matter of fact, they just don't put a leak system. Maybe one of these, this little bypass valve here or something like that. These here. So no, 560 SL does not have a green wire or nothing. So this is the Footwell actuator. This is the fresh air in left and right side, and defroster and the center vent. By the way, in the SLs, the dash vents on the left and full left and right are always open unless you close them. Okay, they don't get different controls. Okay, there's more electronics. There's 2 boxes behind the glove compartment. One controls the temperature, one controls the blower speed. And those 4 switches are right here, kind of behind there. And there's some vacuum hoses there and stuff. This is your idle box, idle control, and I'm not sure which one that is. That's probably part of the alarm system where this came from. But these are the 2 modules that are important for climate control. This is what they look like. Okay, this box here controls the monovalve, which controls the hot water flow, and the compressor. Those two devices are controlled by this box. The blower speed is controlled by this box. Do not lose this. Hope you can ever find them. They are no longer available. We might be able to fix some of them, but I've only sold 2 of them in 30 years, so they are pretty rugged. But don't automatically control it. If your blower speed is a little different, it can be another source. But these, we rebuild these a lot, all the time. Hot water flow in ACC3 is done by the monovalve, it's called. Has a little insert. You can see the top of it here sticking up, but it goes down inside here. This little valve is either open or closed. When there's no voltage applied to these 2 pins, it is open. It just stays open. So the power, it takes power to close it, and that power is provided by that silver box. And it cycles this up and down depending on your temperature demand. On a cold winter day, it'll be open more than closed. On a hot summer day, it'll just send a signal to shut off. Don't need any hot water. This is the hot water flow through the valve here. So this little kit to repair this, be careful. Don't buy the Chinese made ones from, I forget the company. They fail after a while. They are available from Mercedes Benz and more expensive. There is a company that is making new control valves at are different, but they bolt right into place. They hang right up. And contact me if you're interested in that. Here's a AC number 3 system. Also has an auxiliary water pump. This is a picture of it. Now you notice it has about a 6-inch long wire for the electrical connector here. It's the same principle. It's there to provide warm air, hot water or warm air at idle. Now, if you try to buy a pump that looks like this, it's going to be very expensive. I think they're $400 and some odd now from Mercedes Benz. What I've done for many people is substitute the same pump from a 124 car, but it does not have this wire. These 2 pins are right on top of the pump right here. So if you go ahead and install it, then you've got to plug in the wiring harness, and I can make a harness that bridges from here to the harness under the big wiring harness under the hood. So just be aware that I can save you a lot of money by using the 124 pump for $149 instead of $480 for these. I don't know if they're even available anymore. A lot of the aftermarket suppliers used to have this, and then they say no longer available. And then they have the Chinese made ones, which fail after 2 weeks. This Chinese stuff coming into our country is terrible. And the car parts, not just Mercedes-Benz, it's all parts. And beware of where this stuff comes from, mainly brakes and anything else. I mean, there's cheap stuff coming out of that company. But that's how this control here. All right, all your SLs have a little dash, a little grill in the middle of the dash. See that? There it is. What's that for? Inside there is a temperature sensor. That's the inside temperature sensor. It sits in here. Okay, that's how it measures the temperature in the car. Now, how is that accomplished? Well, that's done because there's air sucked into here from this hose, which communicates to the blower housing. When the blower is running, this air is drawn into this little grill through this pipe. Now, what's this foam piece of pipe there? What is there? Well, Mercedes-Benz, again, in making these cars as refined as they possible, that muffles the noise of the blower. I've seen people who have just bridged this. There's a plastic pipe out here off the picture, piece of plastic pipe which goes to the blower housing, and they put garden hose in there, and you can hear the blower running, hear that noise up through here. So the purpose of this, and this is a lot easier to put in, just go to Home Depot. You got to buy 3 feet at a time, cut it about 10 inches long, reach in there and put in. Every SL I've been into under the dash, the original equipment piece is long gone. You'll find pieces of it laying in here, okay? But it's just pipe installation, 1/2 inch inside diameter. You don't have to glue it or anything. It just fits nice and tight. I keep a supply of it here. Every time I sell one, a climate control servo or a push button panel, I send along a piece of this gratis. It's because you're going to need it. And I have a 1-page dissertation on how to get into and replace it. So be aware of that. If this is not there, you don't get very good temperature control because there's no air going into the sensor. So the cabin air temperature is, you don't know what it is. And well, the system doesn't know what it is. So that's how the system learns what the temperature is. So when you want, say, 75 degrees in the cabin, if everything is working right, this will measure it and keep systems working right. Again, if you want 80 degrees on a cold winter day, same thing. But when you get goofy temperature control, that's because there's no airflow through here. You can test it too. When the blower is running, take a match or candle and extinguish it. Watch, see if the smoke is sucked down in there. If it isn't, that means this piece of foam pipe is long gone. It is on every SL. But get in there, pull out the glove compartment box, run your hands up there. You'll feel where it's supposed to be. Maybe the pieces of the original hose are there. The original hose was kind of a white color, and they're all disintegrated. All the heat over the years is disintegrated. And this is pipe insulation lasts much longer. That's probably the primary thing I tell people when they say their temperature control is goofy in system 3. Cooling system here, all these cars, flush the heater once in a while, the heater core. Now you got to disconnect some hoses on the firewall and take your garden hose and back flush it, go backwards through it and flush backwards. Hopefully nothing comes out, but if stuff does come out, that means the same debris is in the servo or the monovalve and it's causing a problem. I've rebuilt over 2,000 of the servo valve from system 2. And some of them, I see chunks of RTV silicone, that blue stuff or black. And that's because people overdid it when they changed the water pump, for instance, and they slathered that stuff all over the water pump mount. And of course, it oozes into the cooling system and it's carried through the heater core or into the servo or later cars into the monovalve. So be aware. Don't use that stuff. It's not supposed to be used like that. Coolant, I recommend MB brand antifreeze. It's the right chemical. Don't buy the cheap green stuff from Walmart. It eats out aluminum. I've seen it. Those servos, the bottom part is made of aluminum, and I've gotten some in there so eaten away I can't even use them. Some of them I have to rebuild a little bit with epoxy because we don't have many of them anymore. So I can tell when people have used that antifreeze is highly acidic. So measure your pH once in a while. You can get a pH meter or test strips of between 7 and 8 is what you want your coolant to be. I recommend in the older cars, Redline water wetter. That's Redline brand. It's a chemical you put a few ounces in your cooling system. It enhances the ability of the coolant to extract heat from the hot metal surfaces. And it actually enhances the ability of the cooling system to keep the engine cool. In an older car, it's a good thing to have. So, you know, some of the engine blocks have deposits on them over the years, and they haven't come off even with flushing unless you want to use a chemical flush, which is a whole dirty process in itself. But Redline water wetter does enhance the ability to remove heat. Water pump lubricant, again, the older cars, you can buy little bottles of water pump lubricant, lubricants that seal inside the water pump, adds a little bit of life to the pump. This is a picture of the section 2. This is the servo valve. Here's a little water pump we're talking about. And if yours is still running, you can test it by unplug the wire, and the brown wire is negative. So jump from negative to ground someplace. The other wire, of course, is positive. And underneath here, you can't quite see it. Your trunk, your cable, your battery's in the trunk. And this long cable comes up front. This is where it enters the engine compartment, is right under here. You can find 12 volts there, and you can jumper that pump and see if it's running. If it's running, hooray, it saved you a lot of money. But let's make it last longer. Let's pull this white plastic cap off. Oops, I'll go back a minute. Pull off, that's the plastic cap, pull it off. This is your transmission dipstick. Pull that dipstick out and dip a few drops of transmission fluid off the dipstick onto that bearing underneath that white cap. That will greatly lubricate this pump. Maybe it'll last quite a bit longer. So that's always a good idea. The lower bearing, if you really want to get into it, I have a squirt oiler, which I go in, you can see that there's a gap where you can get oil into the lower bearing too. And these will last longer if you lubricate. Keep in mind, some cars, that pump's been in there for 30 years, and they get pretty beat up. And if they lock up, I can't repair them. There is a repair kit shown. I've got the repair kit. It doesn't fix them. It doesn't have the right parts. It doesn't have water seal on the shaft, and it won't repair the pump. Take it. I've been digging Mercedes Benz on that for years, but you just have to have a new one. As I said, the 124 pumps are a lot cheaper and they'll work just as fine. Same thing. In this picture, you can see here's all the vacuum hoses. So they come around and connect here. There's electrical connectors underneath it, all that. If you have to pull yours out, the easy way is you can't see between the servo and the firewall here, down behind here, way down there, there's 2 bolts that hold this big bracket that holds the servo and the pump. Take those 2 bolts off and a bolt off this little bracket right here. And undo all the hoses and everything else. You pull the whole assembly out, take it out of the car, and then you can replace the servo and put on there, get all the hoses, everything else, put it back in. It's much easier. You can't reach the servo mount bolts in the car. You have to take the whole bracket out. So just keep that aware if you're going to work on this system. Oh, let me go back here. Yeah, I'll get into blower motor brushes. Cycle once a week. It's a good idea to push the defrost button for a few minutes. That'll exercise the servo and water pump and everything else. It's a good idea, exercising that system. Air conditioning system. I'll get into this in a minute. This is a receiver dryer. If you squat down, open the hood, look, this is the evaporator here, or condenser in front of the radiator. And next to it is a receiver dryer. Now that's not only a reservoir, it's a filter. And inside is a filter. And if a car is as old as all these cars are, if you have to open the air conditioning system for any reason, replace this. You still get them. This is where the low pressure switch is located. The high temperature cutout for the compressor is located. This is where here. But anytime you open up this system, plan on replacing the receiver dryer unless you know it's only a year or 2 old. But I've cut these things open and they're just full of crud from many, many years of operation. So be aware of that. Blower motor brushes. I have some brushes, but it's easier to put a new motor in than put in brushes. You can oil the bearings. It's a complex process because you got to get into the blower, and I'll get into that in a minute here. This is the blower in a 107. If you open the hood, you look at the back, here's this black cover. It's not very black in this picture, but that's it. You take off the screws, and underneath is the blower motor. And then if you want to get this out of there to work on it, the night before, there's 4 bolts that hold this in there, one at each corner. They're probably rusty. Put some penetrating oil on each bolt the night before, a couple of days before. Because if you twist off the stud, because there's a stud that the nuts go on each of the 4 corners, you twist it off, that stud is welded into the body here. You can't replace it. There's no way you can get in there and replace it. You have to devise some way to hold the blower down if you break off that stud. So be aware, you want to be able to get those nuts loose. So put penetrating oil on them 24 hours ahead of time. And then you can get pull the blower out. This is, you can barely see it here. This is the temperature sensor for the auxiliary water pump. But I do have new motors for these. They're Bosch motors, the correct motor that fits it. The Chinese made ones are slightly smaller diameter right in here. And this blower housing is 2 pieces of plastic that are clamped together. Here's the spring clips run here and along here and on the sides. And the blower motor is clamped by the center here. If it's too small a diameter, the blower, it rocks back and forth, and the squirrel cages in here make all kinds of noise. I've seen that. I've had these sent in to me with this brand new Chinese-made blower assembly, and I had to sell them a Bosch motor, which is a correct diameter, and of course move the squirrel cages off their old one and put it on the new one. So I do rebuild these if you need them with a correct Bosch motor. So any questions on that? Good, we're just about time right here. I can be reached at this here. That's my email address, my phone. Don't call me Friday afternoons, please. If you would like to have, I have it shown here, it's a crass commercial message. I have the 107 factory manuals on a CD for $25 plus shipping, if you'd like one. Well, some of these pictures you saw in this presentation are from that CD. but it's got all the diagrams for vacuum, electrical, the works, and how to do this, and how to do that. So it's the factory manuals all on one CD. So I'll be glad to make them up for you. It's a process that I have to go through. That's why I've charged a little bit of my time and effort. But I do have a lot of information on the 107s available. So